Okay. So in our last class, we have started to learn about differentiation of vector point functions. So just for recapping purpose, I am saying we already know or have the idea of scalar point function. Scalar point function matlab mano fx equals to, you are saying x square. Then you can easily understand that whenever you put some values of x, you are going to get a numeric value. Okay. So there is no direction attached with it. Okay. So it is a scalar point function. Example of scalar point function. Okay. Acha. And then we know कि if we want to deal with vector point function, then that means there are components, right? So, mano, I write as the same thing. I write as say f. Now I put a direction sign and x. Then, mano, I am doing all the things in 3D, then 3 dimension. So it will have three components, right? Along y-axis, j-axis, k-axis. That means here it will be a function of x, again another function of x, and again another function of x. If we were in 2D, then it is supposed to have this structure, function of x, one function of x, and then another function of x. Okay. So this is a vector point function. This is a scalar point function. We have already just dealt with it in the last class in details, and we know how to find out the limit of these functions, how to find out the test the continuity of this function, how to find out the derivative of this function. Okay. So today we will see using this derivative, we want to find out the equation of tangent line, tangent direction. That means we are dealing with geometry. Okay. So if we already have this idea, just for the recap only, I'm just telling. Suppose this is this is a vector point function. Then how do we find out the derivative of this function? That means if we want to differentiate this function, differentiate fx, only one variable is there, एक ही variable है, ठीक है, independent variable. This is independent variable because our fx is dependent on it, independent variable x. So if we want to differentiate, then I have to differentiate with respect to x only. So there is no other independent variable here. So how do we do it? This is the notation, nothing to do with the notation, or rather you can also write the dx of fx. Okay, please put this direction sign, and this will be equal to component wise derivative. This formula we have already derived in the last class. I will just use it right now. F1 dash x, F2 dash x. If you are dealing with 2D case, or if you are dealing with the 3D one, that means here, then it will be F3 dash x. Okay. So nothing but for your, just if you want to just memorize the formula, you have to component wise, you have to differentiate. Okay. Now let us see how this gives us, or let us have the idea how this gives us the tangent to a curve. Okay. So first and foremost of all, let us say this is our curve. This is a curve. Okay. And say suppose, as you can see, first of and foremost of all, you can see this is your curve I am saying. So suppose I am dealing with 2D space. Okay. So I have drawn a curve in the 2D space. Okay. So for any point in the 2D space, we know we need two uh, one axis and another ordinate. That is two things we need to specify any point. Say suppose I write P. So I need x and y, right? Okay. So this may be my origin. This may be my x-axis. This may be my y-axis. We already know how to draw a curve. Yes, this curve I denote as capital gamma. Okay. Now another thing, instead of using the Cartesian coordinates, I can also say this curve be a parametric curve. Now, what do I say, or what do I mean rather when I say parametric curve? Parametric curve means here x and y will be function of some another variable, say t. So x, suppose x will be a function of t, and y will also be a function of t. Let's take an example for your understanding. So suppose we are, instead of this arbitrary curve, let us have a circle in our hand. Okay. So once you have a circle, do you know the parametric curve of a circle? I hope you know that. It will be x equals to cos t, unit circle I am taking. Unit circle, that means unit radius. Okay. Unit radius circle, if I take 1 unit, then it will be, or it can be written as this parametric form. So here you see x is dependent on t, y is dependent on t, and t is what? T is your free variable or independent variable. It will vary from where to where? 0 to 2 pi. So that means if you take any point, say here, if you are taking a point, so this point, and this is a position origin. So if I draw a vector here like this, say this is RT, okay, then it is actually having some value, say t equal to say t equal to pi by 4. Then what will be your point at P? R pi by 4. R pi by 4 matlab, R pi by 4 matlab, here pi by 4 I will plug in P place. That means x equals to cos pi by 4. That means 1 by root 2. Y equal to sin pi by 4. Then again 1 by root 2. Then your point will be 1 by root 2, comma 1 by root 2. Similarly, if you take any other point of t, you will get another point here. Likewise, and this will goes on. So that means for any point, let me draw the circle only here. For any point of t you are taking, you are getting a point on the circumference. You are taking another value of t, you are getting another point on the circumference. And likewise, you are moving. So starting from t equals to 0, if I go on changing my t's value, I will get one after another point on this circle. And if you accumulate all those points, okay, you are getting the structure of this circle. So here t is a parameter. We do not say it to a variable, we say it to a parameter. Okay. So this is denotes a parametric curve or parametric equation of the circle. Because circle, obviously standard equation we know, unit circle, if I take the origin as the origin as the center, then this is the structure, this is the equation of the unit circle. Okay. And this again in the parametric form will take this structure. Okay. So this is the thing, if we now consider in vector space, right now I'm trying to deal with vector point function. So suppose I have any curve here. So once you have a curve here, as I said already, if you have any curve here, a point you are taking here, P, and parametric point only, I am taking RT. So this is a position vector, RT. Okay, so this is your origin. With respect to origin, we are measuring everything. So this is a position vector. That means here I am drawing in terms of 2D. So that means here you are getting an x-axis, y-axis. That means here you will be getting two components. One will be R1T, another will be R2T. So that means on any curve, this gamma here, as far as I have drawn here, gamma colon, I can write any point RT will be having two components, R1T, that will be a function of T, R2T, that will be again another function of T. As a specific example, if you take circle, it will be R1T will be cos T, R2T will be sin T, or R1T will be sin T, R2T will be cos T, no problem. Again, if you take a parabola, then accordingly it will be T squared 2T. Okay, for example, if you take the example of parabola, y square equal to 4ax, how can you parameterize it or write in form of parametric equation? See, if you take x equals to 4t, x equals to t square, right? Let me just see what we can put here. 4t square, and here if I put twice a t, sorry, twice a t. Let me check. Just check whether it satisfies or not. 4a square t square. And here one a is missing. See here now, if you put it back here, whether it is satisfied or not. If it is satisfied, then you have taken, or I have chosen a correct parametric form. Otherwise, I need to change it. 2st square. This one I am plugging in, and on the left, it is the left hand side. So it gives you 4a square t square. And on the right hand side, that means this portion, if you put x equals to 80 square, what do I get? 4a into 80 square. That means 4a square t square. So LH is equal to RH. So this form is satisfying this equation. So this is a parametric curve corresponding to this parabola. That means this is a parametric form of this parabola. Okay. So just in the examples I am giving, similarly you may try with other parametric curves also. So one thing, while I am writing this, I am getting any vector position, the position vector you are getting here. Suppose if I take this curve here, here you are getting R1T, R2T as the two components. Okay. So now what is our motive? Our motive is to find out, first and foremost of all, see one thing, while I am drawing it, I am not getting any discontinuity here. If you get discontinuity at any point, what actually happens, while I am drawing some curve, if I have to lift my pen, if I am drawing like this, going on drawing like this, there is no discontinuity, because it is every point you are just moving around your pen on this piece of paper, and you are getting the curve. But somehow, if I consider, say, this curve, this one, then there is a gap. then this one. Okay, and again there is a gap, then this one. Okay, so at this gap, what did I do? I have lifted my pen. You see, there is no green color thing going on through here. Here also, I have lifted my pen. I have not drawn anything here. So these are point of discontinuities. That means at this point, the curve is breaking. So first and foremost of all, when I have drawn this curve, not for one time also, I have lifted my pen. I have drawn it continuously. So this curve is continuous. Gamma is continuous at every point. So once gamma is continuous at every point, then and there only, if your curve is continuous, then only you can differentiate the curve at that point. Okay, otherwise if there is discontinuity, at any point of discontinuity, a curve is not differentiable. So please do remember this thing. I'm not going into the details of this proof because it's a part of the analysis. Only for the vector thing, you need to remember it. He at point, or let me just write it more precisely. A curve is differentiable if it is continuous. Okay, if it is continuous, then you can differentiate it. Okay, but not the other way around. Ki not every continuous curve is differentiable. Obviously, there are some loopholes in there. But the thing is, ki at any point of discontinuity, whether it is instead of writing this thing, let me write like this for your memorization purpose. It is better to write like this. At any point of discontinuity, a curve is not differentiable. Please do remember this thing. So if a curve is continuous, you may try to differentiate the curve. Okay, but if the curve is not continuous, like this, then this, then this, then this, at this point, at this point, at this point, you cannot draw any tangent. Okay, that means if why you cannot draw any tangent? Because you cannot differentiate the curve at that point. Okay, there is no derivative of the function at those points. Okay, so this is the thing. So one, for our purpose now, we are considering कि our curve is continuous. Okay, so I assume for further discussion जो I will be doing right now, I assume my curve is continuous. So there is no question of discontinuity. Okay, so I know the function is differentiable. Therefore, curve matlab curve means here, if I take as I gave the equation of the circle x square plus y square equal to 1, or in the parametric sense, x equals to cos t, y equals to sin t, I will be dealing with this parametric form right now because I want to deal with the vectors right now. And vectors matlab components. So here you are getting two components. At any point on this circle, you can write like x, y. That means you can write like cos t comma sin t. That means you can write any point on the circle as a position vector rt. See? Okay, so with this type of form, we will be dealing right now. Okay, so I am taking any curve which is continuous. That means जो भी यहाँ पे vector function आएगा, that is differentiable right now. Okay, now my question is how to find out the followings. What are the followings? One, point of tangency. That means जो भी point है जहाँ पे you are drawing the tangent, what is the point exactly? That means what is the position vector of that point? PV of the point on the curve where you are drawing the tangent. Where you are drawing the tangent. Okay. Then we will find out direction of tangent vector. This one. And third, equation of tangent line. These three things we will learn how to find out using the differentiation of vector point functions. This is the main thing we will do right now. Okay. So let us start with an example. Okay. Because all these constituents which we'll be using, जो components यहाँ पे use करना है, we already know कि right, we only want to use the differentiation of the function. vector point function. Only that thing is the tool we will be using. So we need to learn how to use it. Okay. So for that thing, let us take an example. Hmm. So let me give one example directly. Let us take the question. We consider rt equal to 4 cos t sin t, where t is something like this. Okay. Now the question is find, as I gave, POT means the point of tangency. POT, this point of tangency I write in short. Okay, here this one. This is POT. Okay, find POT, and the next question is find the tangent vector at POT. Tangent vector, let me say, if it is, I am saying tangent vector, that means I want to find out the direction of the tangent vector. Okay. Acha. So first and foremost of all, as I said, before we start, you see this is a vector point function, right? Again, this is a curve also. How is the curve? You can easily find this curve is actually an elliptic curve. See why I am saying elliptic curve? Can you just guess on your own or have an intuition of your own why I am saying it is an elliptic curve? Because I am saying this curve, you already know the structure of it. Okay, so 4 cos t sin t, right? So my actually here my x equals to 4 cos t, y equals to sin t. So that means x by 4 equals to cos t and y by 1 equals to sin t. So squaring and adding, what do you get? X squared by 16, y squared by 1 equals to 1, because cos squared plus t plus sin squared equal to 1. Okay. So just think, see, you already know this curve. This is an ellipse with major axis 4 unit and minor axis 1 unit. A square plus x square by a square plus y square b square equal to 1. Okay. So this is ultimately a ellipse, but it is in a parametric form. So this is a parametric equation of this ellipse. Okay. Achha. So as soon as this parametric equation is given to us, we are actually dealing with a vector of this form, right? It's a vector point function. Why function? Because t is the independent variable and you are getting a structure 4 cos t. So it is a function of t. Again sin t, another function of t. So jo form we already just now I said a few minutes left before, if f1t, f2t. Like this form is coming. Okay. So this is your vector point function. V P, sorry, let me just denote it like this, VPF, vector point function. So now I know how to differentiate it. Okay. So find out point of tangency, matlab where you are drawing the tangent. So for this curve, suppose this is your curve. So, one thing let me say for the purpose of your exam, you need not show this. Okay. I am showing it for explanation. You need not show it. So let me start doing the sum. What I need to do, let me draw the curve here. This one is a curve because it is an ellipse, a bit of this proportionate it is becoming. So x square by 16 plus y square by 1, that means the major axis is along x axis, you can easily understand, minor axis is along y axis, so I have drawn like this. Had it been the other way around, then you have to change like this. This already you know from the HS part only, I need not say it again. So this is your curve, okay? And what I need to find out at any point, say t, I need to, I am drawing a tangent. I need to say first of all, what is this point t? Now, what is this point t means I need to find out the position vector of t. This is my question actually. First question just corresponds to finding out the position vector of this t. जो यहाँ पे I am showing the figure. Okay, because you are drawing a tangent here. So this becomes a point of tangency. Okay, so one thing you see, if I want to find out the point of tangency, one thing I have just incomplete question I have put, point of tangency at, let me just complete the question, at t equals to pi by 3. let me just rub it out. T equals to pi by 3. You see one thing, as I already said, because it's a parameter, so the small t is having different values along the curve. You take some value here. If you take t equals to 0, then what do you get? 4, the 0, and then, sorry, my mistake, 4 comma 1. Because t, if you put here 0, then you get 4 into 1, and y equals to 0. So this corresponds to this point. Again, for t equals to pi by 6, you will get another point. T equals to pi by 3, you will get another point. So you are moving along the curve, and value of this small t is changing. Okay. So I need to find out at t equals to pi by 3. So suppose I am taking this point. Okay. So it is corresponding to t equal to pi by 3. So if I plug in t equals to pi by 3, which is given in the question, in your given curve, then what do you get? Capital T equals to cos pi by 3, 4 cos pi by 3, comma sin pi by 3. That means whatever pi by 3 means 1 by this, and root 3 by 2. So pi by 3 you are taking, yeah. So this is becoming the point 2 comma root 3. Root 3 by 2 I 4 cos t. Achha. 2 by, sorry, 2, and then root 3 by 2, like this. Okay. So this is the point of tangency. The first part of the question is done. The point of tangency is this one. Point of tangency is 2 comma root 3 by 2. Okay. Achha. Next question, find the tangent vector, that is the direction of the tangent vector. Right. So how do we find the tangent vector? For this, we need to find, second part, to find tangent vector at t. T means, or at as we have already find out the point, I can write at the point 2 comma root 3 by 2. I need to find out r dash t at the point t equals to pi by 3. Now what is r dash t? R dash t means d dt of 4 cos t, comma d dt of sin t at the point t equal to pi by 3. Okay. That means first you differentiate, then minus 4 sin t. This is cos t at the point t equals to pi by 3. That means minus 4 root 3 by 2 and half, whatever it comes, it is your answer. Like this. Okay. Achha. One thing you see, ki this already you have derived. This is the okay. So my point is ki the direction of tangent vector is given by minus 2 root 3. Achha, one thing I have done a mistake, it is half here. So half. Okay. So how does it look in the figure, you see? How does it look in the figure? Okay. So this one minus, what did I get last? Minus 2 root 3 half. Okay. Achha. So minus 2 root 3 half. So actually you are getting a vector, right? Let me write it here. Minus, oh, sorry, here. Minus 2 root 3 by half. This is already we have find out. Okay. Let me change this color a bit. Okay. So here you are saying it is a vector. Okay. So it is your origin, right? So if you want to denote a position vector, how do we denote? We take something like, we draw a vector from this direction. It goes like this. Okay. So this is your actually the vector minus 2 root 3 half. Okay. So what actually I am doing when I am drawing the tangent? I am doing nothing, but I am drawing a line passing to the point of tangency and parallel to this vector. This is actually your tangent vector. So that means that is what I was saying. Whenever I am saying a tangent direction you are finding out actually the direction parallel to another vector. So this is the vector, and how we are finding out the vector? Simply by using the derivative rule of a vector point function. Okay. So this vector I am drawing here, and parallel to this point, parallel to this line, I am drawing a another line passing to the point of tangency. It is touching the point, touching the curve at the point of tangency. So this becomes your direction of the tangent vector. And how it is given? It is given by this vector. And how did you find it out? You find it out by using the derivative of vector point function. So suppose you say you change the point of tangency, right? Suppose I again draw the curve. You can just roughly draw the curve. At this corresponds to for this point t equals to pi by 3. Okay. I have obtained a vector like this, and you have drawn a tangent parallel to this. So this is your tangent direction. Again, you have changed the t equals to say pi by after pi by 360 degrees, so pi by 2 suppose. Okay. So here again another point of tangency. You can again draw a curve because your this curve is continuous, so I can differentiate it. So what I do, I draw another. Let me just remove it first. I draw another direction like this, and then I draw a vector parallel to this. Okay. So that means one thing you see, as you are moving along the curve, one as I change my t, I am moving along the curve, and alongwise, that means simultaneously, as I am moving traversing in this direction, the tangent is also moving like this, right? So sometimes we say it, that is tangent here, tangent helps to determine, or direction of tangent, rather it's better to say direction of tangent helps to determine orientation of a curve, how the curve is oriented. Okay. Curve is oriented matlab ki as you are changing the value of your parameter, how you are moving along the curve. So suppose for this ellipse, you can see if you change the point t according to the function which we have taken, 4 cos t comma sin t. First of and foremost of all, if I say, suppose I take t equals to some value, I am here, then t equals to another value, I am here, then t equals to another value, I am here. Like this, if you jot down all the points, you are going to get an ellipse. Okay. So that means I am starting my journey from here, then I am moving along and again coming back and completing the curve. Okay. Similarly, I could have, if I take any other curve. So suppose I started from here, then I moved here, then went like this, and then this and this and this, and ultimately this. So how do I have an idea about the orientation of the curve? Theory is telling if you go on drawing the tangent at one point after another, so suppose I draw the tangent here, it is giving me the direction, you move in this direction. Then you drawing the tangent here, it is saying you move in this direction. Like this, if you go on, then that will give you the idea of how your curve is oriented in the space. Okay. So this is what we are actually also seeing in our case. Yes, it is indeed giving you the idea ki how my curve is moving in the space. You go on changing the point of tangency, you go on drawing tangents one after another at the point of tangency, and we already know ki if it is the same, there is no singular point, at any point on the curve, you can draw only one tangent. Okay, so you get a specific direction of the movement of the curve. Okay, and in terms of mechanics, those who are from the physics background, you also have the idea कि this tangent to the curve at any point gives you what? Direction of instantaneous velocity. Instantaneous velocity. Okay. Velocity matlab you already know how your displacement is changing with time. So suppose with time your your particle is taking this as your path of motion. So along the path of motion, how your speed is changing with respect to time, that is speed this, sorry, not speed, my mistake. Displacement is changing with respect to time. That is giving you the instantaneous velocity, and that instantaneous velocity geometrically is represented by tangent to the curve at these different points. So suppose my particle under any law of force is moving like this. Sorry, my mistake. Let me just rub it out here. Under any of law law of force is moving like this. What you are doing at any, suppose you have started from here or you have started from here, you draw a tangent. This is the instantaneous velocity IV at this point, say P1. Again you move to this point, P2. Again you draw a tangent. Again this is the instantaneous velocity at the point P2. And likewise, you are going on moving, your tangent direction is changing. It is giving you the instantaneous velocity. Okay. Acha. For exam purpose, let me mention here कि instead of finding out the tangent, they may also just twist the question and ask the same thing in terms of mechanics. Like as I said, कि let the path of motion. I just modify the above question only. Path of motion is given by RT equals to 4 cos t sin t. Okay. Just this point of question I ask, at t equals to pi by 3, find instantaneous velocity of the particle. What do you mean by this? Nothing but the tangent you have to find out. Instantaneous velocity of a particle at t equals to pi by 3. So to solve the question, exactly you have to do whatever I have done till now. That means you need to find out. So RT is here. This is your path of motion. Instantaneous velocity, I'm writing IV in short, at t equals to pi by 3 is given by, then you write r dash t at the point t equals to pi by 3. That means whatever I have calculations I have shown right now, you just put it here, that gives you the instantaneous velocity. So there is nothing new. Actually, they are working about or asking you about the tangent direction only. Okay. So these two things are done. Only one thing is left till now. How to find out the equation of the line of the tangent, right? The equation of the line of tangent is also very easy. Why equation of line of tangent is also very easy? Because you see, using the vector idea, we already have done this so many times in our previous classes. Ki suppose any line is here, okay, any vector, okay. Okay, let me draw in tangents motion motive only so that you do not get confused. So this is your tangent. So one thing, let me just complete this. Whatever you know, this is R0t. I'm just writing R0t because this is a specific point. Say P now, R0t. So this is your R0t vector because it's origin. So this is the point which is lying on this line. And this line is parallel to some vector, as I already said. So say V vector. Okay. So how do we find out equation of a line? Equation of a line passing through a point, passing through a point, say P, which is R0t, and parallel to a vector, say V. How do we find out? We have done it several times in the class. It is given by, recall back, it is given by R0t plus, okay, let this be unit vector also you may take here, or it will be adjusted within this vector symbol only. Let me just see one. Unit vector I take, so that I can control the other thing within this scalar thing. So let me take S V cap means unit vector. Okay, so that means this point is lying on this vector, on this line which you are trying to. My question is what? You find out this, find out the equation of this line, right? Equation of this line. This is our question, right? So what I am doing, I am taking one point is fixed on it because the point of tangency is the point through which the tangent is passing, and you take another any other point on it. Okay, any other point on it, R. Okay, so R minus R0, this is your R, this is your R0. So from the triangle law of vector addition, R minus R0 is also on this line. Okay, again R minus R0, so R minus r0 is on the tangent line. Okay. Again tangent line TL I am writing in short is parallel to this unit vector, is parallel to V. So that means R minus R0 parallel to V. So if R minus R0 is parallel to V, that means what? R minus R0 will be some scalar multiple of this V. So that scalar multiple I am saying say S. Hmm? So I can say R minus R0 equal to SV. So this will give you the direction of the, sorry, not the direction, but the equation of the tangent line. Direction already we have got as is V. Let me write it properly. V. Okay. So this will give you the equation of the tangent line. Okay. So let me write like this. Let me do one sum so that you understand here. Or you can do it with this sum also. Let me complete this sum only. So suppose that this, I extend my question. My question was two part it was having earlier times. You see, find tangent vector, point of tangency. Now I add this third question. Third question, find equation of the tangent line. Okay. If I add this up here, so what is the, I need to find out the point. I already have find it out. Okay, so this is your R0 is T here. This is R0, 2 by 2 comma root 3 by 2. So let me carry it forward. So here for our question it is R0, 2 root 3 by 2, and V also. First of all, V, not the unit vector, but the direction corresponding to the tangent line. What did I find out? Let me just see. Minus 2 root 3 by half. Minus 2 root 3 comma half. So let me write it out here first. Minus 2 root 3 comma half. So what is the unit vector? You can find it out easily from here. 1 by root over 4 into 3 means 12 plus 1 by 4. Whatever it might come, you have to tackle it. Minus 2 root 3 comma half. Okay, so this is the unit vector. Okay, r minus r0 you can get from here. R minus R0 means R means what? X comma Y you may say. Okay. So from here only you can get out or rather take out R minus R0 matlab X minus R0 two components X minus 2 here. So X minus 2 comma Y minus root 3 by 2. Y minus root 3 equals to S. So this is actually your parameter. You may say here T also. Okay, whatever S or T, anything you use here, and this V unit vector. So if I simplify it out, it will be what 40 49. So it will be, just check once also, 40 plus and 49. So 7 by 2. So 2 by 7 actually. 2 by 7 minus 2 root 3 comma half. So you can just simplify it out. So x minus 2 component wise I am saying 2 root 7s into minus 2 root 3. So this x equals to 2 plus, this minus is there. So 2 minus 4 root 3 by 7 is this, and y is equals to, so this component equal to this component. So a this one, not this one. Okay. So y minus root 3 by 2 equals to 2 into half into s. So s, that means y is equals to s plus root 3 by 2. Okay, let me write it root 3 by 2. So this is your equation of the tangent line. Okay, the equation of the tangent line you are getting in this form. Okay. So this completes our idea for finding out the three tangent line, point of tangency, and direction of tangent line, also equation of tangent line. So as a homework, rather you check on your own whether you are can find it out or not, because this is the type of question you may be getting for your exam. So let me consider this one. Question. Consider the curve RT equal to t, comma 1 by t plus 1, comma 2 by t square plus 4. Okay. Question is very easy. We find tangent vector at t equals to 2, and this is first. Second, find equation of corresponding tangent line. Okay. So you can easily find it out. For the first part, what you need to do, the tangent vector, first part, TV at t equals to 2 is given by what? Given by r dash t at t equals to 2. So you can easily do it from here. Okay. And then what? For the second part, first we need to find out the point of tangency because we need r0. Okay. So point of tangency at or for t equals to 2 is what? RT for t equals to 2. So RT matlab whatever values are given, you just plug t equals to 2 here. So that means root t plus 2, that means root 2 plus 2, comma 1 by t plus 1. So 2 plus 1, comma 2 by t square plus 4. So this thing. So this is your point of tangency. That means this is your actually r0t at the point t equals to 2. So r0 you have find out. So equation of line of acha, r0 you find out the unit vector along tangent direction. This is given by what? This vector, whatever vector you will be finding it out here, you just normalize it. So you can do it here. So let us calculate. Okay. So let me calculate r dash t. This r dash t matlab root ddt of root 2 this thing ddt of 1 by t plus 1, and third component ddt of 2 by t square plus 2 by t square plus 2. Okay. So that means this check once also this thing and this one minus 2t. So therefore r dash t direction of the tangent के लिए I need to put t equals to 2 because for this is the where you are drawing the tangent as per the question. See, I have put in the question the tangent vector at t equals to 2 I need. See, tangent vector at t equals to. So I need to plug in t equals to 2. Okay. जो भी क्वेश्चन में दिया हुआ होगा I have to put it there. So accordingly it is done. 2 this is extended up to this. So 2 into 2, so 4, and here 2 3 9, and here minus 2 into 2, then 2 square, 4 plus 4 16, 8, so 64. Okay, so here ultimately you will be getting 1 by 16. 1 by 16. Okay. So this is your r dash t. So unit vector now you can find out unit vector. But there is a unit vector as I asked for here along tangent direction. Okay. Along tangents direction will be nothing by this thing. Just normalize. So you have to just know this thing. I need not do it actually here. You can understand on your own. You complete it. So whatever you get, so your line of tangent line equation of the line of tangent equation of tangent line is better to write. Please write at which point. This is very important. Do not miss this thing at t equals to 2, because if you change it, everything will change. You can easily understand it. So equals to r minus rt at the point t equals to 2 is equals to whatever, if you put s, r dash t at the point t equals to 2. Okay? And this, all these things you have already calculated. This also you have calculated here. RT at the point 2. This is the thing. This one R0. So you just plug in everything here and you get the answer. Plug in, you get the answer. Okay. So this is how you do the sum. So let us stop here.